So we're back and we're going to do a couple calculations to just take a look at the comparison of values, future values in this simple problem as we change the compounding periods. So what I want to do is put our compounding periods up here in this top row, and I'm just going to add that up here to the top. And here with annual, we know that the compounding period is 1. With semi-annual, we're going to compound twice. Quarterly, we're going to compound 4 times. Monthly, we're going to compound 12. And daily, it's either going to be, depending on what your book tells you, it's going to be 360 or 365. We'll go ahead and use 365. Okay, so for our future value, we're going to do the problem the exact same way here, except we're going to add in an additional element to include in this compounding period. So we're going to go ahead and incorporate this in so we can copy our formula over for all of our other cells. So I'm going to come down here and I want to choose my function wizard as we've done in the past. And I want to click on my future value. I do see an error here. Let's go back up here. We need to put present value here. I copied this over from a previous problem. Okay, so this is $5,000 and this is 8%, 5 years. Okay, so I think we've got it all in there now. All right, so we want to click on our wizard, go to our future value, and this should be looking familiar now. We're going to now click on our different components for our formula. So we're going to go to our rate first. Then we want to go to our number of periods. Then we're going to go to our present value. We're going to put this in as a negative and click on our present value. Now, the only other thing that we need to do is we need to adjust for our compounding periods. So right here on your rate, you want to come back up here and you want to divide your rate by the number of compounding periods. So we're going to just do a divide symbol here and put in the number of compounding periods right here. Then on our number of periods, we want to come down here and we want to multiply by that number of periods here. And that is our only addition that we need to do to our formula. And now we can copy this over to all of our other cells. So we can click OK here. And this is going to give us our future value of this $5,000. But not only this future value, but we can get on our fill handle right here at the corner of our cell. And if you haven't done this before, this allows us to copy this formula over. So what we need to actually do is select all of these cells right here. And we want to copy them over to all of our other cells. And that's going to give us all of our answers all the way over. So if we double click on one of these cells, we can see that we're still pulling from the correct cells. Okay, so on this last one, we are going to try a different way of solving this. We can't really use the present or the future value function to solve a continuous problem. So I've got the formula up here in the cell for you, and we're going to solve this using E for continuous compounding. So we're going to start out with our equal sign, and we are going to click on our future or our present value, and then we are going to multiply that, and we are going to use the EXP function. And then we're going to put in our number of periods, which I kind of have to go over to get to on my copy. And then I'm going to multiply that by our percentage rate for interest. And then I'm going to close that and then hit enter, and we should get our answer. And that, you will see, is even higher than our daily rate. So it is the highest amount of interest that you can earn on this amount of money. So you can see this progresses along with the compounding periods. So the more compounding periods that you have, the higher interest you are going to earn on your money, with continuous compounding being the highest, or the limit, what we call the limit. So that is the special circumstance of compounding.